This presentation about Jackson's crossed cylinder. It is a combination of two cylinders of equal strength but of opposite sign placed with their axes at 90 degrees to each other and are mounted into a handle. This is a minus half. This is a plus half cylinder. This is the handle formed 45 degrees to the axis, and the power of the cylinder is 1. So you can think of the crossed cylinder as two cylinders perpendicular to each other of equal power but of different sign. Or you can think of it as a spherocylindrical combination. Here in this example, we have a sphere of minus half. The whole 360 degrees is minus half. And we have a cylinder of plus 1. So this cylinder is effective here, and the net result will be plus half. So this is the same as the one above. So a typical Jackson cross-cylinder lens is a spherocylindrical lens having a spherical power component combined with a cylinder power component of twice the power of the sphere and of opposite sign. Cross cylinders can be of different powers, varying say from half, this is formed of two cylinders each is 1/4, 1, 1.5, 2. The power of the cross cylinder used varies according to the cylinder we are testing on the trial. For example, if the power of the cylinder tested is small, we go for small cross cylinder, and if it's high, we'll go for a high power cross cylinder. On using the cross cylinder, first we check the axis. Supposing this is example with a patient, we are checking that he has a cylinder of a power -1 in this eye. So the second eye is closed. This is the cylinder and the trial frame, and this is the axis. We start by checking the axis of the cylinder. We apply the cross cylinder in such a way that the handle is in the line of the axis of the cylinder tested. Then we ask the patient to look at the chart, and we make flipping and ask him which is better, the first position or this new position. Suppose the patient told us the second position is better. As we are dealing with a minus cylinder in the trial frame, we keep an eye on the minus sign of the cross cylinder. The minus was first here, and on flipping it is on this side, and the patient sees better when the minus on this side. In such a way, we are going to rotate the axis of the cylinder in the trial frame to the direction of this -1. Then we are going to repeat. Now we change the position of the handle of the cross cylinder to be exactly in the new position of the test cylinder. Then we do flipping again. Suppose the patient told us it is better on this way. So again, we are going to rotate the cylinder tested in this direction. The first one we'll do in 10 degrees rotation, but now we are going back, we'll do it in 5 degrees rotation, and then we're going to repeat this several times till we reach to the end point when the patient tells us that he see equally in both positions. There is no difference between first or second position. Now we're going to check the power of the cylinder. Suppose this is the axis we came to and we want to check the power. Now we are going to apply the cross cylinder in such a way that the power of the cylinder of the cross cylinder is in line with the axis tested. This is the first position and I'm flipping. Suppose the patient told us that he see better with this position. In this case, we are going to increase the power of the cylinder from -1 to -1.5. If he chooses the plus, that he sees better, then we are going to reduce the amount of the cylinder. And instead of being -1, it will be -0.5. But we need to change the sphere as well. In this case, we are going to add the half amount of the cylinder. So the -0.5 will be a plus quarter sphere. And in this case, as we add plus cylinder, we are going to add also minus sphere of half the power. So whenever we increase or decrease the power of the cylinder in the trial frame, at the same time, we are going to add half the amount in a sphere of opposite sign. Why is that? Because actually the cross cylinder we are using, it affects both meridia and it has an effect of plus half and minus half. So we need to change everything. Why the patient will see with one position better than the other? Let me remind you of the conoid of Sturm. If we have a surface with one power horizontally as a power to be focused on this point, and the vertical is more strong, so it will be focused in another point closer to the lens. Now we have one anterior focal line and circle of least diffusion and second focal line. The conoid of Sturm is the area between the focal lines. If the amount of astigmatism is small, the conoid of Sturm will be small. On the other hand, if the difference between the two meridia is large, then the conoid of Sturm will be large. So the higher the difference between the two meridia, the wider the conoid of Sturm. So in one position, when the lens is coinciding with the error we are testing, once it was minus, another one it was positive. As we change, one of them will make the conoid of Sturm long and the other one will make the conoid of Sturm short. So whenever the conoid of Sturm is shorter, the patient will be happy. Now, what is the value of using the cross cylinder? Why we don't just use any cylinder from the trial case and ask the patient? When we are using a cross cylinder, The cross cylinder affects the two meridia, the one we are testing and the 90 degrees. While if we get a cylinder from the trial case, we can add one or decrease the other. Simply you are affecting one meridia and not the other one. So in case of cross cylinder, as the effect is on the two meridia, the conoid of Sturm will be nicely noticed by the patient as being worse or good, as being long or small. In case of just using simple cylinder from the trial case, the effect is only in one meridian. So cross cylinder get a better chance for the patient to notice the difference. Now practically how we are going to use the cross cylinder. The first step in cross cylinder refraction is to adjust the sphere to yield the best visual acuity with accommodation relaxed. Focus the eye to be examined with plus sphere while the patient views a visual acuity chart. Then decrease the fog until the best visual acuity is obtained. In case of astigmatism, decreasing the fog places the circle of least confusion on the retina, creating a mixed astigmatism. Then ask the patient to look one or two lines above the best vision so he can notice changes. Then we're going to use the cross cylinder. The starting point of using the cross cylinder can be to use the cylinder in a previous prescription or the cylinder in the auto-ref results or the cylinder in the retinoscope. Another way to check for the cylinder is by subjective retinoscopy. If the starting point contains no cylindrical component, we can use the cross cylinder in 4 cardinal meridia to check for any astigmatism, or we can use a cylinder from the trial case. In case of using the cross cylinder, we check these 4 cardinal positions. This is vertical, plus or minus. This is horizontal, plus or minus. This is oblique. And this is the second oblique. Suppose the patient chooses this one as best position. Then I'm going to have a cylinder from the trial case and put it and start to do what we started with, is to check the axis, then the power to adjust this cylinder. If we are going to start with the lenses in the trial case, we add a cylinder, change the power of the sphere by half amount, opposite sign, then ask the patient to rotate the knob slowly to check for the best vision. Suppose the patient chooses this position as being the best, then we refine the results by using the cross cylinder. We are going to recheck the axis, then the power using the cross cylinder. Thank you for your attention.